Hello, I'm Roshan recording experiment 3 of that online lab. So, experiment 3 is about the first question is to import a data set with missing values. So, we have a data set called adult and let's see what is in it. So, it has information about adults and their age, their working, their work class, the marital status, and also their income. So, we have income as a label here, so I use a set role operator to set it as a label and then to replace the missing value. So yeah, to replace the missing values, I use replace missing values operator and I use the average method to replace the missing values. Then mm, I also normalize the data set for easy computation and okay, uh, let's go in a different order. So here we are asked to normalize the data, so I use the normalization operator, and for normalization I use range transformation, that is, I set the values of all the numerical attributes between 0 and 1. If you put a breakpoint here and check it, you can see that all the values have been brought down to values, have been scaled down between 0 and 1. And after that, in that question, you can see it says use different techniques to replace the missing values. Hmm. So we have the Mario operator here and different techniques. So you could pick any technique and um, run the code to run the application. That's it. Now we have remove highly correlated attributes. So when attributes are highly correlated, it just increases, like, they pretty much acts the same with the results. So if they have the same interaction with the results, there's no point in computing something. Again, it's just a waste of computation, and if the data set is pretty big, the best option is to remove one of it. So first, what the operator does is it finds out the correlated attributes and then removes it, and that's that. And then we have split validation and cross validation. So that goes here. So we took the data set and we fed it to two different operators, and one is the validation operator, which is split validation, and the other one is the cross validation operator. In split validation, you split the data set in a ratio um, as training data set and testing data set. The training data set is used to generate the model, and the testing data set is used to test the model. So here we gave the 0.7, that is basically 70%. So if you run the code and compare both of validation and cross validation, you could see a difference in accuracy. The cross validation usually gives a better result, and cross validation, what it does is it validates every instance against every other instance, so it is considered a better method than validation. So you can see here, okay, if you go inside and see it's performance 4 for the validation and performance 3 for cross validation. In 4 you have the accuracy of 85, and in 3 you have the accuracy of 84.48. So we can see that split validation says more accuracy and cross validation here gives lesser accuracy value. But that's not always the case. It's mostly cross validation which is a better method of validation. The next question is, yeah, now we can use the different descent tree. We can use the descent tree algorithm. So we have the algorithm here, and let's put a breakpoint after that. And when you run the code, uh, yeah, when you run only a descent tree, it is going to generate a tree model, and we'll be able to see that pretty soon. And single injection loop operator is also going to do the same thing. It's also going to give one. Yeah, this is the model that is generated. It is not As you can see, if the branches are too much and if there is like a lot of sub branching, it's not a very good algorithm for the given data set. And to test it, you use the apply model and the performance operator. What apply model does is it takes every model and it will make it into a form that it can be used for computational purposes. And if you look for the performance here, you can see performance 2. Performance 2 is this, and it has 82%, which is lower than using split validation cross validation on this one. And the last one is single row induction, and this is another technique of classification. And if you see for a breakpoint and see the result, it's gonna give pretty much rules, I guess. So, you again use apply model and performance attributes to judge the performance of uh, the model. So yeah, these are the rules we have generated by the algorithm. And if we run the entire thing and look for yeah performance there, the performance is 79. That is the accuracy of the rules generated by single induction rule, single attribute algorithm, and that is all. Thanks.